For almost 4 years I've been looking at this image almost every day. This is Revit's splash screen introduced in Revit 2019. And almost every day my question was, can this really be made in Autodesk Revit? So this is a video about how I tried to replicate this splash screen and what it would look like as a real building. So grab a coffee and enjoy. So at first I downloaded Revit's splash screen image in higher resolution and examined it thoroughly. And as I previously expected, the image is very heavily photoshopped. You can see that it's probably made out of 2 of 3 separate images that are probably cut and stitched in Photoshop. So here we can see the main structure, and there are many lines that are probably just drawn onto the image in Photoshop or any other image editing software. My initial idea was to make this only in Revit, without the help of Dynamo, but when I started to play around in In-Place Mass Editor, I realized that it's much slower to edit the surface only in Revit, because I don't know the exact form of the object, and I don't know how many times I have to remake the surface, so I decided to use Dynamo. Here you can see that the main surface is made out of ellipses, with the main curve that is hosting those ellipses. So here I can easily edit the radiuses of the ellipses and see the surface right away, and I don't have to redraw anything. Here you can see the first surface that made out of 6 ellipses, and here you can see that I have the lead curve made in Revit, and it's made out of 5 points that are hosting a spline. So basically I can move those points around in Revit and see how the surface changes with them. So here I reselect the new lead curve, and now here you can see that I'm just playing around with those diameters and radiuses of those ellipses. At first the surface wasn't made because it's overlapping, and when I change the diameters I can get the surface to exactly the shape that I want, and that's what I do. I just look at the splash screen image, so I just try to get the right camera angle from where the image was taken, and in that way it's easier to guess the shape of the whole structure. So that's what I do here. I just look at the image, try to get the camera angle and change the radiuses of those 6 ellipses. And also I can change the position of those ellipses on the lead curve, and that dramatically changes the shape of the surface. And here you can see that I just slide those ellipses back and forth, trying to guess the right shape. And as I played around with those ellipses, I figured out that I have to add a surface for the ground and push the start and the end of the lead curve below the surface, so that the main surface starts and ends below the ground level. In that way I can get closer to the right shape that is made in the Revit splash screen. And also in the splash screen you can see that the main structure starts and probably ends below the ground. It's also kind of apparent in the Revit splash screen that the structure begins and ends below the ground level. So now here I'm still changing those radiuses of those ellipses, and I'm still trying to guess how the shape was really made in the Revit splash screen, how to get to the shape. And here you can see also the bug for the Dynamo. Also, although the surface for the ground was colored in green, here you can see that it's on this angle is just black. So there's definitely something wrong with the shadows or with the lighting of this 3D preview in the Revit Dynamo. So the next big problem was when I tried to push the surface into the Revit mass surface using form by loft cross sections. It just wouldn't push the surface into the Revit mass family. So what I had to do, I had to retrace those ellipses so that the cross sections aren't made out of continuous ellipses, but it's made out of splines that have a beginning and an end point. So it's not continuous surface. And in this way the form by loft cross sections node didn't throw the error and actually did push the surface into the Revit. So when I had that problem figured out, I still had a lot of work on the shape of the real surface. The next step was to get the grid lines onto the surface in Dynamo, so I can get a better look at how I have to rotate the surface to get the shape that I need. And that was also a real struggle, because I have to rotate the surface, and I have to rotate it in a way that doesn't break the surface. That's first. And the next thing is that I have to rotate the surface so that the grid lines kind of follow the splash screen image. And as you can see in the image, the grid lines are kind of very wavy. They just don't go straight from the beginning to the end of the surface. And here I add the points to the grid because my first thought was to get the grid points and add an adaptive family to the grid using Dynamo. And the next part is where I model that adaptive family. And basically it's a very simple basic 4-point adaptive family. And here I just add lines between those adaptive points just to make the shape that I want to replicate. And there are no surfaces and there are no solids in the family because I want this family just for testing purposes. And if it works, later I will add the surfaces and the solids and the materials and everything else. But here you can see that my plan actually failed. The depth of the structure doesn't align and overlaps, so clearly this doesn't work. And I have to use different solution for this structure. So not wanting to give up, I tried again this adaptive family, because my first thought was that there's something wrong with the Dynamo or with the family. So I tried a different depth and different family, but it also failed. So it's clear that there is a different solution, different method of constructing this structure that Autodesk uses. And the next possible solution that came into my mind was to use divided surface in the mesh family. So here you can see what the divided surface in the mesh looks like. You have a surface, then you click on divide surface, and then you can add different parameters to this divided surface. You can add the grid lines and rotation of the grid, and that's what I try to do. And when you have the grid, you can add curtain panel pattern based family to the grid, and it kind of applies to the grid. So here I'm making the first curtain panel pattern based family. It's very simple family in the beginning, also just to test that it works better than the adaptive family. It's similar to the adaptive family, as you have 4 adaptive points, but they're fixed in the position, and you cannot change this position. You can change the grid pattern, and then all you do is add your geometry accordingly to those 4 adaptive points that are fixed. And here what I do, I just add the basic solid and basic model lines to those adaptive points, just like in previous family, just for the testing purposes. And when I apply that family to the divided surface, it works much better than the adaptive family. And in the depth of the family, everything works and nothing is overlapping. So when I get that right, the next thing was to add some kind of structure to the family that looks like in the Revit splash screen, some kind of pipes that kind of holds together the whole structure. And this is where the real fun begins, because I don't know why, but in the beginning I couldn't get the pipes populated onto the divided surface. So what I did, I made reference lines that is a leading lines for those pipes, and then I made a profiles for those pipes that is a circle. And when I select those 2 reference lines, the circles and the leading lines for the pipes, and press create form, it creates a pipe. And that is exactly what I need. The problem was that I couldn't get the pipe that is perpendicular to the surface. All the pipes that are parallel to the surface populated very well, but the pipes that are perpendicular to the surface didn't populate on the divided surface. So I tried multiple times and multiple configurations, and all of them failed. And to this day I don't know why it happened. It just threw an error that it cannot make this mass or this form, and it just wouldn't make the perpendicular tubes or pipes. And for a while I thought that the problem was in the surface or in the grid of the surface, because some places the grid cells are too small or too narrow for the families to populate the exact pattern that I want. So I try to remake the surface and remake the grid. And basically for a while I just ignored the problem and just played around with the grid to get the shape more close to the image of the splash screen. And here you can see I'm doing that, and again I'm making the form, making a surface and dividing a surface. And again I'm trying to add this surface to the Revit mesh family, because not all surfaces are accepted by the form by loft cross-section nodes in Dynamo. not every surface gets exported. So that is also a problem, because I can get the shape and the grid lines as close as possible in the Dynamo 3D viewer, but I cannot export them for some reason. So I have to readjust the surface and readjust the grid so I can export it. And in the end, the surface that I exported to Revit wasn't the closest surface to the splash image that I made in Dynamo. And here again, I'm making a new curtain panel family. And here you can see that there's another problem for the Revit itself. It's very, very slow to populate the divided surface with these families. And just a few seconds ago, you could see my task manager with the processor load, and I have i7 Intel processor with 8 cores. It's not the newest processor, but it's not the worst. But the problem is that the Revit doesn't use all the power of the processors, all the computing speed. It just uses barely, 20-30% of the computing speed when it calculates and when it populates those divided surface, and that is very, very painstakingly slow. I have cut out much of the portions from the video. Basically, it took, half an hour, 20-30 minutes, maybe an hour to populate a grid with 2,500 cells. And again, here you can see that I'm struggling with the family. It's the same problem as before. It populates the surface, but it doesn't make all the pipes that I want. Here you can see that it's only 2 pipes made. And I thought that it was because of the shape of the surface or the shape of the cell. But here you can see that the most basic cell with almost 90 degrees of the angles in the corners also doesn't get populated. And here you can see one of the smallest cells. But when I change the size of the grid in the family, everything works as expected and there are no errors. So that got me very frustrated for a time. And then I reread the help for pattern components, and there in the best practices there's a sentence that says, using sketched lines, create extrusions and forms to give the component dimension. Another tip is to switch border tile to empty or to full, not as partial, and that way it kind of speeds up the calculation and the population of the divided surface. And now I'm remaking the surface again and trying to get the closest shape to the splash image. And the first tip about using sketched lines to get the extrusions and the geometry got me thinking, maybe I have to use not the reference lines as a guides, but maybe I have to use a model lines as a guides. And in the next few seconds you can see that I'm remaking the pipe extrusions using not reference lines but model lines. And for the testing purposes I divided the surface to 20 by 20 grid, so it's faster calculations. And here you can see that I'm rechecking that the depth is working and there is no overlap in the families. And here you can see that this is the first time that I got the perpendicular pipe working, and in that moment I understood that there's kind of a difference between using reference lines and model lines when creating these extrusions or these forms like pipes. And I don't know why, but when I use model lines, every pipe is extruded and every cell is populated. And I have no errors when populating the divided surface. So finally it works, but it gives me another layer of struggle because it's a bit difficult to create a parametric family using not reference lines but using model lines. So for example, it turns out that I cannot change the radius of the pipe by adding a parameter to the profile of the pipe, to the one profile that is in the middle of the model line. But that I will discover later. For now, I'm just happy about that I can populate the whole surface without any errors. And here you can see that even the smallest of the cells are populated exactly as I want. And there are no errors and all the pipes are made. So now I'm just focusing on dividing the surface so it looks as close as possible to the splash screen. But when I rotate the grid in the Revit, it just doesn't give the same rotation as in the splash screen. So I just try to rotate the surface even more in the Dynamo and then export the surface to the Revit. And here you can see that it's again populated without any errors. And I can change the division count for the surface and it's again populated. Now I'm adding a camera to the scene so I can start to render the first images. And here I'm adding material parameters to the family so I can change the materials later as I render the scene. Here I'm selecting all the pipes and adding visibility and material parameters to those pipes so I can later turn off and on the pipes and change the materials. And this is when I discover that when I try to change the radius of the pipe, it just bulges out. It just doesn't change the radius for the whole pipe. And that is the problem that I talked about previously, because the form from the detail lines acts, in my opinion, kind of differently than the form that is created from a reference lines. And here I'm trying to mitigate that problem by adding two profiles to this pipe. One in the end and one in the beginning of this lead line. It kind of works, but it's difficult to snap those profiles to the beginning and to the end of this model line. And here you can see my first try to use two profiles for the pipe. It works in the way that it changes the radius of the pipe, but when I try to populate the surface with this family, it throws a bunch of errors and it doesn't populate the whole divided surface. And yeah, here you can see that I delete all of the pipes and I try to make all of those pipes again with the beginning and the end profile. So I add points to those lines and add a parameters for the beginning and the end so that they stay on the beginning and the end of the line. And next you can see the problem with this is that when I change the size of this family, one end of the pipe follows the grid, but the other end of the pipe doesn't follow the grid. And I don't know why is that. You can see when I change the size of the grid, some ends of the pipes follow the grid, but some ends doesn't follow the grid, and that is a problem. And I try to lock those ends of the pipes and align them to the beginnings and the ends of these adaptive points, but kind of nothing worked. I also tried to make an extrusion from the profile, but that doesn't work either. So what did work? In the end, I had to add those profiles exactly to those points in the beginning and in the end of the pipe. I had to set the work plane on the point, and then I had to draw a circle in the beginning and in the end. And then when I select those two profiles, I could make a form, a pipe that I wanted that follows all of those points, and I could change the radius of the pipe. So here's the surface populated with those curtain panels, and what I do here, I select those curtain panels and I switch on the visibility of those constructions, because not all of the surface is populated with those pipes, and most of the surface is populated with non-transparent panels. So initially my idea was to make one curtain panel family with the visibility parameters, so that I can turn on and off the pipe visibilities and turn on and off the concrete visibility. So that is what I do here. I select the panels and I turn on the construction visibility, the pipe visibility, and turn off the concrete visibility. And here are the first renders. And the problem with this was that when I try to change the material, let's say for the pipes, it takes way too long to recalculate the whole model. But for now, I'm trying to render the first images and to see what it looks like. Do I need to change the color of the materials? And where the sun is shining from, and the angle of the camera, and how do I get the reflection in the glass. And next I noticed there is vertical ribs in the glass structure, and that is what I'm adding here, a material parameter to the side of the glass panel. And next I had an idea to make not just one family with all the visibility parameters to the pipes and to the concrete, but to make multiple families, because when Revit has to populate the surface, divided surface, with this one family that have all the information about the pipes, it has to calculate all the locations, all the possible locations for the pipes. So when I create multiple families with one family that has only just the plane for the concrete, it has to calculate only 4 points and the surface between those 4 points, and it's much faster. So that's what I did. I just created 3 families. One family was non-transparent concrete family, other family was a concrete family with the side, and the third family was the structure family with the pipes and with the glass. And then I have to populate the divided surface with the non-transparent concrete family, and it's much faster. And then I just have to select those curtain panels that have the construction and the glass in them. And that's what I do here. I'm going over the whole structure and selecting one by one the concrete panels that have to be glass and changing them to curtain panels with the glass and with the pipe structure. This is a kind of a boring task, but it's much faster than if I try to populate the divided surface with the one family that has all the information in it. It took me about half an hour to 40 minutes just to populate this one divided surface with the curtain panel. So this is the final shape and the final model for the splash screen render, and now I'm changing a few more panels just to see that they fit the image nicely and as I expected. And next I'm onto the rendering. This will be super fast forward part because I'm only changing materials and material properties, and I'm changing the sun position to match that of the Revit splash screen image. So here are more rendering, changing the sun and rendering again, and rendering again and again and again. So basically what I want is I want to catch the reflection of the sun in the top of the structure in the glass, and that is kind of a difficult task. If you have to re-render every image, it takes about a minute for the image to render, or maybe a bit less, and then I have to change the sun's position, and re-render the image. And here I figured out that I need another family. This was the second family I mentioned, the concrete family with the side, and this is the side of the side panel where the glass meets the concrete. So it just doesn't float in the air, but it kind of pushes against the side of the concrete. Here you can see that this is the side panels that I'm selecting and adding this side concrete slice. And here I figured out that I need to change the grid size to 70 by 50. So now it's not 2,500 but 3,500 cells in the grid, and it looks a little bit better. The model is bigger, but the cell size is a bit smaller, and it looks much like the image in the splash screen, because the whole surface is not a square, it's more like a rectangle. But when you have an equally divided grid, let's say 50 to 50, the cell looks more like a rectangle, not a square. But I want it to look like a square, so I have to divide the surface to 70 to 50 ratio. And in this division, each cell looks more like a square, not like a rectangle. And that is what I want. So at this point, I figured out that I need another light source, or maybe 2 light sources, because the sun is shining from the right side, but I have to get the reflection in the glass on the left side. So that is why I need an artificial light in the left side of the image. And you can also see that in the Revit splash screen, that in the left side there is warmer light. So I figured out I need at least 3 lights on the left side of the image. And the next step was to create another grid inside of this grid. So I figured out I need to offset the surface to create another surface inside this one, to divide it and add a octagon pattern to this surface. And that is because there is another structure inside of this structure. It's like a pentagon frame that carries all of the outer shell. And you can see that if you look really close to the Revit splash screen image. At first I tried to offset the surface onto the inside, but that wasn't successful because I couldn't export the surface to the Revit. The next idea was just to make the surface exactly the same size as the previous surface, but with a much simpler grid division and surface rotation. So I exported that surface and divided that surface, and I added octagon pattern to that surface. And here you can see the octagon pattern. And next I have to make an octagon curtain panel pattern based family that is offsetted on the inside from the main surface, and that is what I'm doing here. So there is one point in the middle of this octagon and all the lines meet in the middle. So at first again I make model lines and I populate the surface with this family to verify that this is the pattern that I want. And then, as before, I create a solids onto those lines. This time I cannot change the dimensions parametrically for those frames, but I just kind of don't need it. I just eyeball the dimensions and populate the surface. And the last task was to add 3 columns in the middle of the structure. So that's what I'm doing here. These are just in place generic models that I just place in the middle of the closest form. Here I'm just aligning them and sizing them accordingly to the image of the splash screen. And now the model is finished and onto the rendering. Here you can see all of the renderings that I saved. I'm basically trying to get the lights right. I'm trying to get the reflection from the artificial light, changing the background to white, changing the material for the ground, changing the colors for the frames and for the concrete. And this is the final render that I made. This is the large size render that I edited in Photoshop just to match it as close as possible to the splash screen. And here you can see the final image. I did overlay the lines from the PDF, and here you can see the comparison between my image and the Revit splash screen. And I know that it's not perfect, and the grid is not just like the Revit splash screen, and the shape is not just like the Revit splash screen, but I think it's close enough, and I'm quite pleased with the result. So I figured I could send this model to Twinmotion to see how it would look like if the Revit splash screen was a real building, with the cars and the people and the trees and the sounds of the city. And I hope you did enjoy this overview of this crazy model, and please enjoy the next clip from the Twinmotion, and see you in the next video.